if we have this object and only this force in this direction, in this vector direction, is pulling it, that means perhaps it could have come from here, it could be brought to here if it is being pulled only in this direction. So maybe by pulling in this direction by this force, which is given as 5 Newton, it could have been brought over here. On the other hand, if it was just pulled in that direction by another force q, then it is possible that this object could have been brought over here just by pulling this. But that's not the question. Both of these forces are being applied on a single object, and the question is, where would this object end up if that is happening? So we can guess that it is definitely not going to be just over here, or it's going to be over here. So maybe somewhere around here there's going to be a resultant force that is going to act on it, and maybe it will end up over here. So the question is, what would be the overall force that this certain object is going to experience, and where is it going to go, in which direction? Now whenever they're talking about direction, we can express that direction in terms of an angle. So we know that if we give the direction in terms of this P force, that could be this angle, or it could be through this Q, it could be this angle. So how to do this? How to solve this problem, which would have been much simpler if there was only one force pulling it towards this direction. So now what we do over here is basically known as a parallelogram rule. So we imagine that if this is the point and there is a force acting on this direction and another force acting on this direction, so what we do, we just copy this into this so that they are parallel. So we just copy this over here so that it is parallel, and we just copy this force. So this force is now over here. Now what we do over here, we just copy this force over here. So that means this force, if we just copy this parallel force over here, is going to be this. So that now they look like a parallelogram, and the overall force that acts on it is going to be the diagonal of the parallelogram. That means this is going to be the overall force by which this is going to experience. So this object is now going to experience an overall force that's going to make it move. So what is that going to be, and how does this work? How do we use the parallelogram rule for finding the overall effect of force when different forces are acting on a single object? Now one of the things that we have to understand is the rule of parallel lines. If this angle is 40 degree, that means the angle between the force Q and the force P. Now remember, force Q has been replicated over here. That is exactly the same, parallel and equal. It's a parallelogram. Opposite sides are parallel and equal. So this if two lines are parallel, we have to use the concept of supplementary angles. When we have two lines that are parallel and a transversal joins them, that means if this is theta, this angle is going to be 180 minus theta, known as supplementary angle rule. So they are supplementary angles. So in that case, this angle is going to be 180 minus 40. So this is going to be 140. So now we can basically think of the resultant force as a new triangle, where it can be like this. It's a non-right angle triangle. So this is the resultant force. These are the other two forces, P and Q. So this is P, this is Q. We know P equals to 5 Newton of force and Q equals to 3 Newton of force, and we know this angle is 140 degree by supplementary angle rule. So all we have to do is find the resultant force F. They're calling the resultant force F. So we can use the cosine rule to do that. So using the cosine rule. So the cosine rule is the rule for finding a side or angle if it's a non-right angle triangle. So we know that this force, so this force squared equals to 5 squared plus 3 squared minus 2 into sum. It's the product of the included angle. These two sides make the angle, so we product of those two sides. So 5 into 3 into cos of the angle enclosed by them, which is 140 degree. That is the cosine rule. So then we can calculate it. This is 25 plus 9, that is going to be 34, minus this is going to be 30 cos 140. So therefore f square equals to, so square root of 56.98 Newton. Find the degrees to one decimal place that the angle that the resultant force F makes with the force P. So the direction is going to be a particular angle that they're asking for. So let me call this angle theta. So for this, using the sine rule, we can now use the sine rule for this non-right angle triangle to find this angle theta. So this is going to be sine theta divided by, so the opposite side is this 3 Newton, equals to, we know this angle 140 degree, so sine 140 degree divided by, we know the opposite side, the resultant force is going to be 7.55, and then we can write by simplifying sine theta equals to 3 sine 140 divided by 7.55. So that means sine theta equals to, so theta equals to sine inverse of 0.2554, and then the angle is, so 14.8 degree. So that's the idea. Now sometimes you have to understand one thing. This angle can be acute or obtuse based on how the diagram has been drawn. So if the diagram has been drawn in the format so that it looks like an acute angle, then we can say it is 14.8 degrees. So if the diagram is like this, so this is 14.8 degree. But on the other hand, if the diagram is drawn like this, in that case, this is going to be the obtuse angle. So it depends on the situation whether it's an acute angle or an obtuse angle. But if nothing is mentioned, it doesn't really matter